Okay, tonight I asked you guys to practice these LOL diagrams, and we kind of lost track of time in some of the classes here. So I just want to kind of run through those. We want to make an LOL, which is basically just a graph, a graphical representation of what's happening to energy for every time that this switches a trend. So we're going to make an LOL here for A to B, and then we're going to add an OL for B to C to show that transition. And then we're going to add another OL for C to D. And then we're going to add another OL for D to E. And then finally, we're going to add another OL for E to F. Okay, and I'm going to just show you what happens here. So we have basically two different kinds of energy. We have what we call phase energy. And this is energy that's being used to change phases. That's literally what it means. Is phase energy is energy being used to change phases. So anytime that we have a plateau, we're going to assume that all of that energy is being used not to change the temperature or to make the particles move faster, but it's being used instead to change the phases. Then we also have what we call thermal energy, which is just heat, and that energy is the energy used to make particles move faster. Okay, so again, even though we have a solid, it's still moving. There's the particles inside are still moving. So when we first start this, we start with phase energy and we start with thermal energy. Let me just make this a little bit smaller just to make it a little easier. And so we start with a little bit of each of these. And we've got some solid that's inside of here. So you can draw your little solid particles inside. And coming in is some more energy. There's some blocks of energy that's coming in. Now, how do I know that there are blocks of energy coming in? Because I put it on a hot plate. That made the particles, that meant that the particles that we're coming into contact with were moving relatively quickly. So I'm adding energy to it. If I would put this on a cold plate, such as you would use at like a cold stove creamery, that would take the particles and make them move slower if the temperature was changing. Again, if we're not undergoing a phase change. So now here, when this energy comes in, because the temperature is changing, it's moving up, because the temperature is changing, all of that energy is being used to change it thermally. So we have some energy that's coming in. Now, in this next part, the line looks about the same as the line here. So we're going to go ahead and just toss in two particles here. And again, but this is where it's changing phases. So again, this is for the partially solid, partially liquid stuff. And it's changing phases, so it's all going to the phase energy. So this is my EPH, the phase energy, and this is my thermal energy. Now again, energy is coming in. Now if I look at this line, if I were to straighten this out, it would be a little bit bigger. So I'm going to add this as 3 bricks of energy. It looks like it's about maybe a third bigger or so. And that's being added to straight liquid. And so now, again, that's making the particles move faster. So now I've got 9 bricks, or let's see, got 9 bricks, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is obviously not to scale. And then 4 over here. Okay, so here's my phase energy. Here's my thermal energy. Now if I look at this line over here, that line looks like it's about as long as that liquid line over here. So again, I'm going to erase this real quick. And I am going to add 3 more bricks of energy here. Let's make this a little bit smaller just to make my life easier. 3 more bricks of energy, and that's being added to stuff that is just about to change into a gas. So again, I've got my liquid over here, got 3 bricks of energy. So now I'm going to add 3 more to that. Ooh, that should have been 7 on the thermal. Sorry guys. Should have been 7 here. And so now I've got 4, and I got 3 more, so that's going to be 7. So here's my EPH and my E thermal, and now I've got 7 and 7. So I got an even number again. 7, 7. And then down here, my gas, I just got a little tiny bit that it changed, it looks like. So I'm just going to add a little bit. And I'm adding it to something that's already a gas. And all it's doing is making that gas move even faster. So if I look at this from E to F, in that, I'm just adding more to my thermal energy instead of my phase energy. So now I've got, it looks like 8 of these. And then 7, oops, make this a little bit smaller. 7 of those. So I got a little bit more of the thermal energy, just another brick more than the phase energy. And so again, all that we're trying to do by these graphs, we're just trying to make it a little bit more understandable. If you understand the particle picture part over here, and you understand the graphing part over here, and you understand all of this, you kind of see how it all sort of fits together. So again, our I can statement tonight, I can understand the graphical particle picture. Here's my graphical, my particle picture we did in class, and my LOL, or the energy model here. And each one kind of helps to support the others. So I'm hoping that by doing all of this, you start to see how all of this is related. We're going to get to the math part when we get back from break. But we're going to talk a little bit more about this and take a look at some other scenarios besides just water tomorrow. Okay? You guys have yourselves a great night, and I will see you in class tomorrow.